Alright, hi guys. So in this video we're going to be doing another practice test kind of walkthrough. So I'm going to be doing an additional maths paper from the May-June 2017 session, paper 1, version 2. So I've actually taken off one part because it's about matrices and that's no longer the syllabus. So this is going to be a 70-mark paper minus the because it's without the matrices now. And it's going to be 1 hour 45 minutes just to account for the 1.5 minutes per mark kind of thing. So what I'm going to do is I'm just going to go through this paper and kind of explain my thought process along it and just, give you guys an idea of maybe how you want to approach problems in the exam. So let's get to it. All right, so I'm going to start the timer. 3, 2, 1, now. Okay, so on each of the Venn diagrams below, shade the region which represents a given set. So we've got A union B intersects C. So obviously there are brackets, so you want to focus on A union B first. So I'm just going to draw that using this kind of stroked lines. So I'm just going to shade A union B. That's all of A and B because A union B means everything that A and B have. And then intersect C, which restricts it to whatever part of that A union B is touching C. So that's going to be represented by this section over here. So the part where two lines have gone over, two directions of lines have gone over, that's the part we need. So that therefore, looking at that, it's going to be this part we shade. Because this is the part that intersects with C, but it's still the union of A and B. Alright, so you can just roughly shade it and it doesn't have to be too perfect or anything, like mine's definitely not. So let's move to the next part. So A intersect B union C, so it's just basically the opposite. So A intersect B is only this part where it intersects. But then union C is where it also meets with C. Union C means it's also the parts where C are included. So we can also shade in everything else that falls into this little C bubble. Let me just shade it. It doesn't have to be perfect shading, just roughly shading it. And this part is all where C is, and it's a union with the part that A and B intersect at. So it looks a bit like this shape over here. All right. Now, the next part says A prime intersect B prime intersect C. So basically, A prime is all the parts that don't include A. So it's all the parts outside of A, whatever, all this. And then B prime is all the parts that don't include B. So that would be everything B doesn't touch. And the intersect C part is the part where C is included. So A prime intersect B prime does not really include any of this. Sorry, so it doesn't include any of this. This part is not included because that is not the intersect of the two functions, right? We have to look at what's not A and not B. And then the intersect C means that it's going to be probably equal to just C, this part. So this is really saying the same thing as only the section that's only related to C. It's it's not intersecting with anything else. It's just C. So it can't be any of the sections that are with A and B because A prime intersect B prime does not cover that. All right, great. Let's move on to the next problem. All right, let's go to question 2. So it is given that y is equal to 5x squared plus 4 to the power of half all over x plus 1. Showing all you're working, find the exact value of dy over dx when x equals 3. So this is a perfect example where we need the quotient rule. So the quotient rule states that for f of x in the form of u of x over v of x, the derivative of f of x should be equal to the derivative of u of x times v of x minus the derivative of v of x times u of x divided by v of x squared. So let's identify our u and v and then differentiate them to find the two derivatives. So we got u of x in this case is the one what's on the numerator, so that's 5x squared plus 4 to the power of half. Then, therefore, the derivative by using chain rule is equal to half times 10x. Oops, that looks like a 70. 10x times 5x squared plus 4, and then you decrease the power by 1. So negative half is now the power. On the other hand, you have v of x, which is equal to x plus 1. Therefore, the derivative is just going to equal 1. Substituting this into our formula, we get derivative of u of x, which is equal to, well, this here we can simplify down to 5x. So you can say that this is 5x times 5x squared plus 4 to the power of negative half times x plus 1 minus the derivative of v, which is 1, times u of x, which is 5x squared plus 4 to the power of half, all divided by v squared, which is x plus 1 squared. And if we substitute 3 in here, we don't even need to simplify it down. We just need to substitute 3. Substituting 3, we get 5 times 3, which is 15, times 5x squared plus 4. So 5 times 3 squared is 45, plus 4 is 49. To the power of negative half is 1 over 7, times x plus 1, which is 3 plus 1, which is 4. Minus 5x squared plus 4, we already established with x being 3, 5x squared plus 4 becomes 49. 49 to the power of half is 7, so minus 7, divided by 3 plus 1 squared, which is 16. And this gives you 60 over 7. And then we want to have a common denominator just so that it's easier to subtract these. So 7 times 7 is 49, therefore 7 can be represented as 49 over 7. All divided by 16, which is equal to 11 over 7 times 16. And I'm just going to star this and bring it over here. So the answer is 11 over 112. dy over dx is equal to 11 over 112 when x is equal to 3. All right, let's go to the next one. So vectors I and j are vectors parallel to the x-axis and y-axis respectively. So the vector v has a magnitude of 3 root 5 units and has the same direction as I minus 2j. Find v, giving your answer in the form ai plus bj, where a and b are integers. So same direction as I minus 2j. What we can do is find the magnitude of that and then multiply it by a certain factor in order to get it to the magnitude that's desired. So I minus 2j, we can find the magnitude by doing root and then the coefficient of I squared, so that's 1 squared, plus the coefficient of j squared, so that's negative 2 squared. And that is equal to root of 1 plus 4, which equals root 5. So given that vector v has a magnitude of 3 root 5 units, we can just multiply I minus 2j by 3. So we got 3 times I minus 2j, which is equal to 3I minus 6j, and that's our vector v. So A is 3, B is negative 6. All right, so for part B, the velocity vector w makes an angle of 30 degrees with the positive x-axis and is such that the modulus of w is equal to 2. Find w, giving your answer in the form root ci plus dj, where c and d are integers. Okay, so it says it makes an angle of 30 degrees with the positive x-axis and is such that w is equal to 2. The magnitude is equal to 2. So we can just set up a Pythagorean formula. So we can say the root of the coefficient of I squared, so root c squared, plus the coefficient of d squared, the coefficient of j squared, sorry, which is d, is equal to 2. So we can say that the root of c plus d squared is equal to 2. If we square both sides, we know that c plus d squared has to equal 4. So that's one equation that we have. Then says the vector w makes an angle of 30 degrees with the positive x-axis. So now we have to figure out the direction. So if we have root c units to the right, this is root c, and then d units up, then this over here should be 30 degrees. So we can say that tan 30 is equal to d over root c. So we can actually put in tan 30 and see what the result is, just so we know what we're working with. So tan 30 is the same thing as, if we just draw the triangle, 30, we have root 3, 1, 2. So tan 30 is root 3 over 3. So this is equal to root 3 over 3. So d over root c is equal to root 3 over 3. And we can actually rearrange to get d is equal to root 3c over 3. And then we can substitute this in here to solve for c. So you get c plus root 3c over 3, which is squared, is equal to 4. Just scroll down. So c plus 3c over 9 is equal to 4. So that means that 9c plus 3c equals 36. So 12c equals 36. So c is equal to 3. And then if we find d, well, d, we can find that using c plus d squared equals 4. So, So we know that c is 3, so 3 plus d squared must equal 4. Therefore, d has to equal 1 because it's also on the positive x-axis. And it's making an angle of 30 degrees, which means it's going up. So therefore, the answer is root 3i plus j. That's the vector. All right, so let's go to this question now. So the first three terms in the expansion of 3 minus x over 6 to the power of n are 81 plus ax plus bx squared. So find the value of each of the constants n, a, and b. So the first part we have to recognize is that the constant is only represented by 3 to the power of n. So we can compare like terms and say that 3 to the power of n is equal to 81. Therefore, n has to equal 4 in order for this to be true. So that's our first step done. Now we can just get the expansion of 3 minus x over 6 to the power of 4 for the first three terms, and then solve for a and b. So 3 minus x over 6 to the power of 4 is equal to 3 to the power of 4, which is 81, plus 3 cubed times negative x over 6. Remember that we decrease this power by 1 and increase that by 1 for each term. And then we multiply this by the combination 4c1. And then you add it to 3 squared times negative x over 6 squared times 4c2. Remember, the combinations follows Pascal's triangle. And we don't even need to go further because they only want us to look at the first three terms and compare. So we can use inspection to do this. So 3 cubed, well, let's look at this term first. So 3 cubed is 27 times 4, which is 108. 108 divided by 6 gives you 18, and there's a negative sign. So therefore, we have 81 minus 18x. And then if we look at the value, so let's look at the third term. So you have 3 squared, which is 9. And then you have 6 in the denominator, but that's being squared. So that's 9 over 36, which is 1 over 4. And then you multiply that by 4c2. 1 over 4 times 4c2, which is 4c2 is 6, is 6 over 4, which is 3 over 2. So we have plus 3 over 2x squared. Therefore, n is equal to 4. We've already established that actually already. So a has to equal negative 18 based on the fact that that's the coefficient of x, and the coefficient of x squared is b, which is 3 over 2. So that's our answer. Let's move to the next question. Question 5. So a particle P moves in a straight line such that the displacement x meters from a fixed point O, t seconds after passing O is given by x equals 4 cos 3t minus 4. So velocity with respect to time is basically differentiating this function over here. So dx over dt is equal to v, which is equal to, so we can just differentiate this, we get negative 12 sine 3t as our answer. So I'll just write that. Hence, write down the maximum speed of p. Well, if we say negative 12 sine 3t, sine 3t is equal to 0. We know that sine 3t has to equal 0 then. Therefore, 3t is equal to pi over 2. So t is equal to pi over 6. Sorry, wait. That's my apologies. See, I can also make mistakes. So they're asking for the maximum speed. That means we just need to find a way to make negative 12 sine 3t as big as possible. And the way we can do that is we can actually just differentiate this function again and set it to 0. So dv over dt, so we have v is equal to negative 12 sine 3t. Then we can say dv over dt is equal to negative 36 cos 3t. And if we set this to 0, then we can find the maximum value. So we can say that cos 3t is equal to 0. Therefore, 3t is equal to, it could be equal to pi over 2. It can be equal to various things. So we can just say, for example, let it be equal to pi over 2. Then t has to equal pi over 6. So if we substitute pi over 6 into our original equation, we can get pi over 6 is one solution. The other solution, that let's just write down a range of solutions. So t could equal pi over 2, 3t equal pi over 2. It could equal 3 pi over 2. So therefore, t would be 3 pi over 2. That would be equal to pi over 2. So t could equal pi over 2. So if we just test out these two values, for example, well, we know that putting pi over 6 in there will give a velocity of negative 12, but putting pi over 2 in there will give a velocity of positive 12. So therefore, the maximum is equal to positive 12. This here is a minimum value, this here is a maximum value. Therefore, we can say the velocity is equal to v is equal to 12 meters per second. That's the maximum speed. Find the smallest value of t first. Oh, the other way you could think about this is the fact that sine can only be a maximum of 1 and a minimum of negative 1. And when you're multiplying a negative value, you want to make it as negative as possible in order to make it a positive value, since negatives cancel out. So therefore, negative 1 should be what we set sine 3t equal to in the first place. Find the smallest value of t for which the acceleration of p is 0. So what we can do is differentiate. We've already done that. We know that the acceleration, which is equal to dv over dt, is equal to negative 36 cos 3t. So it's asking for the smallest value of t for which the acceleration of p is 0. So we're just going to set this to 0. So it's equal to 0. Therefore, cos 3t is equal to 0. 3t has to equal pi over 2. Therefore, t is equal to pi over 6. So it's equal to pi over 6 seconds, as that's the smallest value that can make this equal to 0. All right, let's move on to the next question. For the value of t found in part 3, find the distance of p from O. Okay, so we just plug pi over 6 back into our displacement function, which is 4 cos 3t. So x is equal to 4 cos 3t minus 4, I believe. Yeah. So we find the distance using t is equal to pi over 6. So we can say x is equal to 4 cos, and then pi over 6 times 3 is pi over 2 minus 4. So therefore, x is equal to negative 4. However, remember that they're asking for the distance, and distance can only be positive. Therefore, we say the distance is equal to 4 meters from origin. Or O, rather. All right. Let's go to question 6. So show that cosec theta over cotan theta plus tan theta is equal to cos theta. So what we can do is, I always like to write this in terms of sine and cos. It's just a lot easier to work with than working with tans and cosecs, etc. So cosec theta is the same as 1 over sine theta. Cotan theta is the same thing as 1 over tan theta. And since tan theta is sine theta over cos theta, we can say that this is equal to cos theta over sine theta. Then tan theta, of course, as I just said, is equal to sine theta over cos theta. And now we can substitute these into our identity. So this gives us 1 over sine theta over cosine theta, so that's cos theta over sine theta, plus tan theta, which is sine theta over cos theta. So first thing I want to do, I'm just going to erase this. Then move this over. First thing I want to do is combine these two fractions. It's really ugly when it's just on its own. It's hard to work with. So what we can do is multiply, we can cross multiply. We get 1 over sine theta over, then cos theta times cos theta. So cos theta squared cos squared theta, plus sine theta times sine theta, which is sine squared theta, over the common denominator, which is now sine theta cos theta. So we know that sine squared theta plus cos theta is actually equal to 1. Therefore, we can say that this is equal to 1 over sine theta over 1 over sine theta cos theta. When we divide, we can express it as 1 over sine theta times, and then the flipped fraction of the second one. So that would be equal to times sine theta over cos theta. The sine theta cos theta. And then the signs cancel out, and you're left with cos theta, which is equal to RHS as required. I would always recommend labeling it LHS, so I'm just going to write LHS, and then make sure you say that it's equal to RHS as required. All right, for the second part, it says it is given that the integral with bounds 0 to a of whatever we just simplified is equal to root 3 over 4. So find the value of a, giving your answer in terms of pi. All right, so this is basically the same thing except using 2 theta instead of theta. So we can deduce that cosec 2 theta over cot 2 theta plus tan 2 theta has to equal cos 2 theta. So therefore, we're looking at the integral with boundaries 0 to a of cos 2 theta is d theta is equal to root 3 over 4. So now if we actually just substitute a and 0 in the bounds, we get, we have to first integrate. So integrating it, we get half sine 2 theta with the bounds not yet applied, a 0, which is supposed to be equal to root 3 over 4. And now we can actually apply the bounds. So we get half sine 2a minus half sine 0 is equal to root 3 over 4. Then let's just bring it up. Since half sine 0 is equal to 0, we can just say half sine 2a is equal to root 3 over 4. Multiply by 2, we get sine 2a is equal to root 3 over 2. Here we can say that 2a is equal to the inverse of sine of root 3 over 2. So if we were to draw the triangle, we know that sine 60 is equal to root 3 over 2. So therefore, 2a is equal to 60 degrees, which is the same thing as pi over 3. And therefore, a is equal to pi over 6 radians. So that's our answer. And this also fits our bound of 0 to pi over 4, so that would be correct. All right, let's go to the next problem. So it is given that y is equal to a times 10 to the power of bx, where a and b are constants. The straight line graph obtained when log y is plotted against x passes through the points 0.5, 2.2, and 1.0, 3.7. Find the value of a and of b. So they're telling us that it's a straight line graph, and if we know linear law, we have to basically rearrange this to make it into straight line form. So if we take the log of both sides, considering we have a 10 to the power of bx part, we can say log y is equal to log a plus log 10 to the power of bx. Because remember that if you combine logarithms, the insides get multiplied together, which is shown here, but we just split it up. So we can say that log y is equal to log a plus bx log 10. And we know that log 10 is equal to 1. So we can just say log y is equal to bx plus log a. And this is in straight line form. We can just say that y is equal to log y, m is equal to b, the gradient, x is equal to x, and then c, or the y-intercept, is equal to log a. And now let's just assume that we have y equals mx plus c. And let's find the equation of this line. So if we say that, if we substitute, if we find the gradient first, we can do this using y1 minus y2 over x1 minus x2. So let's just say that this is x1 comma y1, and this one's x2 comma y2. Then our gradient is equal to 3.7 minus 2.2 over 1.0 minus 0.5. This is equal to 1.5 over 0.5, which is equal to 3. So we have y equals 3x plus c. And if we substitute one of the points there, we can find what c is. So let's take this point over here, 0.5 comma 2.2. So we have 2.2 is equal to 3 times 0.5, which is the same thing as 1.5, plus c. So c is equal to 0.7 then. We can check this with the other point, but we don't really need to. So we have our equations y equals 3x plus 0.7. And if we're finding the values of a and b, we have to compare. So let me just move this to the side. So we compare each of the things. So we know that the gradient is represented by b, so therefore b equals 3. And we know that log a is the same thing as 0.7. So we can say log a equals 0.7, and therefore a equals 10 to the power of 0.7. If we put this into our calculator, we can find out what a is. So I'm just going to do that right now. 10 to the power of 0.7, which is equal, so a is equal to 5.01. So those are our solutions for a and b. Let's move to the second part, where it says using your values of a and b, find the value of y when x is equal to 0.6. So we know that y is equal to a times 10 to the power of bx. So y is equal to a times 10 to the power of bx. In this case, we know what a and b are. So we can say that y is equal to 5.01 times 10 to the power of bx. In this case, is 3x. And it says when x is 0.6. So y is going to be equal to 5.01 times 10 to the power of 3 times 0.6, which is the same thing as 1.8. And then when you put this into calculator, times 10 to the power of 1.8, you get 316.11 as your answer. Or you can write this as 316, just to be to three significant figures. And then they said to find the value of x when y is 600. So we know that when y is 600, the best way to do this would be writing it in this form over here. So we know that log of 600 is equal to bx, which is the same thing as 3x, plus log a. And in this case, that's 5.01. So you can say log 5.01. This is also known as 0.7. So we have 3x plus 0.7 is equal to log 300. So we know that 3x is equal to log 600 minus 0.7, and therefore x is equal to log 600 minus 0.7 over 3. And this is equivalent to, so let's just put this into our calculator. Log 600 is log base 10 of 600 is equal to 2.778, etc., minus 0.7 divided by 3. So therefore, x is equal to 0.693. And you can actually check this. All you have to do is put this back into the formula. So if we say y is equal to a times 10 to the power of bx, and we have x, we can say y is equal to 5.01 times 10 to the power of 0.693 times 3. So 10 to the power of 0.693 times 3 gives you 119.95, and then you multiply that by 5.01, and you get approximately 600. So this is correct, which is approximately, it's actually 601, but it's approximately correct. So we can say x is equal to 0.693. All right, so let's move on to the next problem. So a 5-digit number is to be formed from the 7 digits 1, 2, 3, 5, 6, 8, 9. Each digit can only be used once in any 5-digit number. Find the number of different 5-digit numbers that can be formed if there are no restrictions. The number is divisible by 5. The number is greater than 60,000. The number is greater than 60,000 and even. So there are no restrictions means that we have 5 spaces that can be filled. I always like to draw these boxes. 1, 2, 3, 4, 5. What that means is when we have a total of 7 digits to choose from. The first box, you can choose any of the 7 digits. The second box, you can choose 6 because one of them has already been picked in the first one. Third one, 5. Fourth one, 4. And then 3. So we have, the answer is going to be 7 times 6 times 5 times 4 times 3. Let me just put that down. 7 times 6 times 5 times 4 times 3. This is the same thing as 7p5. Which is equal to 2, 5, 2, 0 combinations, or permutations rather. The number is divisible by 5. So if we draw this box again, 1, 2, 3, 4, 5. Well, it's divisible by 5 means that it has to end with a 5. Therefore, the last box only has one choice, to end with a 5. Now, with the first box, since we already used the 5 somewhere, there are going to be 6 options, then 5, then 4, then 3. So that's equal to 6 times 5 times 4 times 3 times 1, but that's the 1 doesn't really matter. That's going to equal 2520 divided by 7 basically, and that's equal to 360. Now the number is greater than 60,000. So the way you would do that, so let's just draw these boxes again. Always draw boxes, it's always helpful. So 60,000 can only be greater, it starts with a 6, 8, or 9. So therefore, there are 3 choices for what it can start with. However, in the second box, already 1 would have been picked. So therefore, there'll be 6, then 5, then 4, then 3 options. So the answer is going to be 6 times 5 times 4 times 3 times 3, which is the same thing as 360 times 3. And that's equal to 1,080. All right, and now you have the final problem, which is actually the hardest of the lot. So the number is greater than 60,000 and even. So there are 2 options here, and you should articulate both of them. So scenario 1, I'm going to write that, is if 6 or 8 is first number. So obviously it's going to change depending on whether the first number is odd or even. Because if it's even, then there's 1 less number that can go at the end. So if the 6 or 8 is the first number, let's start with that. Let's draw the boxes. 2, 3, 4, 5. Really badly spaced boxes, but whatever. So if 6 or 8 is the first number, there are 2 options because they obviously has to be greater than 60,000. And now we're left with 6, but we can't go to the next ones yet. We have to go to the last one first to make sure we satisfy the even condition. So we've picked 6 or 8 as one of them. Therefore, there's 1 less even number. In total, the number of even numbers in the digits given are only 2 of them. There's 2, 6, and 8, and one of them's already been taken for the beginning. Therefore, the ending is only going to have 2 options as well. And in between, all the other digits can be used. So we've just removed 2 digits from the 7. So we have 5 options left, 4 options, and 3 options. So this can be 5 times 4 times 3 times 2 times 2, which is equal to, let's just put it in the calculator, 2 times 2, which is equal to 240. And then the other scenario is if 9 is the first number. Because then you have more even numbers to work with. So what this means is that when we're drawing this out, so the first number can only be 9 because we picked 9 as the first number. But the last digits, there are 3 options, considering the fact that an even number wasn't used in the beginning, there are 3 even numbers. So the rest of them can be filled as per usual, 5 times 4 times 3, which is equal to 5 times 4 times 3 times 3, which is equal to, I'm just going to put this in, 5 times 4 times 3 times 3. That's equal to 180. So that's why the total number of permutations. Remember that this is a permutations question just because they're asking about numbers, and 1, 2, 3, 4, 5 is different from 5, 4, 3, 2, 1. Just remember that. First identify if the permutations or combinations question. So 240 plus 180, which is equal to 420. So that will be our answer for this problem. All right, let's go to the next part. So Ranjit has 25 friends, of whom 15 are boys and 10 are girls. Ranjit wishes to hold a birthday party but can only invite 7 friends. Find the number of different ways these 7 friends can be selected. If there are no restrictions, only 2 of the 7 friends are boys. The 25 friends include a boy and his sister who cannot be separated. So the first one is find number of different ways these 7 friends can be selected. In this way, we're going to use combinations because it doesn't really matter the order in which he picks them as long as he picks them. So that's why it's going to be 25C7. And let's just put that into the calculator to find out what the value of 25C7 is, and therefore the number of combinations is. So there are a lot for this one. This is 480,700 different combinations. Then only 2 of the 7 friends are boys. So basically, we have to look at this from both a boys and girls like choosing perspective. So let's look at how many ways we can choose the boys. So we have 15 boys, therefore 15C2 is going to be 2 of the 7 boys. The 2 of the 7 people. So 15 choose 2 is equal to 105. And that's the boys' end. The girls must make up the remaining 5. So therefore, there are 10 girls and 5 are to be selected. So 10C5 equals, let me just put that in. $252. In this case, we cannot add them. We have to multiply them because the 2 scenarios are linked. So if we multiply them together, so 252 times 105 is equal to 26,460. All right, let's go to this problem here. So this is the last part of the permutation section. So the 25 friends include a boy and a sister who cannot be separated. All right, so we can kind of just think of them as one unit. So basically the fact of the matter is that if the boy goes to the party, the sister will also be going, and if the sister doesn't go, the boy won't be going, whatever, all that. So what we're going to have to do is assume that the other spaces are up for grabs. So let's say scenario 1. Split this into scenarios again. Scenario 1. Both go to party. In that case, there are 5 spots open for 23 people. So that would be 23C5, which is equal to, let's just put that in our calculator. And it's going to be equal to 33,649. Now, the second scenario is neither go. So by now, we have 7 spots open for 23 people to vie for. 23C7, and putting it into our calculator, we get 278, it's not 278, sorry. We get 157. Now if we add that to the 33,649, we get 278,806. So that's the total number of combinations for that. Let's move to the next one. Now let's move on to the next problem. So we're almost done. We just have to go through a little bit more, but we'll be almost done. So the diagram shows a circle, center O, radius 8 cm. The points A, B, C, and D lie on the circumference of the circle such that AB is parallel to DC. The length of the arc AD is 4 cm, and the length of the chord AB is 15 cm. I'm just going to label all that. So if 4 cm is the arc AD, then BC is also going to be 4 cm just because it's symmetrical. And the chord AB is this line over here. So therefore, that's going to be equal to 15 cm. So they're asking us firstly to find in radians angle AOD. So AOD is going to be this angle over here, this little pizza slice. Let's call it theta. And basically we know that the arc length of a sector, this is a sector, is found by taking the radius and multiplying it by the angle inside. So we can say 8 theta, which is the angle, is equal to 4, and therefore theta is equal to 4 over 8, which is equal to 0.5 radians. All right, so hence show that angle DOC is equal to 1.43 radians. So let's just identify DOC first. This here is DOC, we're going to call this alpha. And we can use the cosine rule actually to find what DOC is. So let's just assume first, I'm just going to erase this. Let's assume first that AOB, which is this angle over here, is alpha, and we're gonna find alpha first, and then from there we're gonna find what DOC is. So using the cosine rule, we know that 15 squared is equal to 8 squared plus 8 squared minus 2 times 8 times 8 times the cosine of alpha, and let's just solve that. So 2 times 8 times 8 is the same thing as 2 times 64, which is 128. So 128 cos alpha is equal to 8 squared plus 8 squared, 128 minus 15 squared. So 128 minus 15 squared is equal to 128 minus 225, so that's 15 squared, and that's equal to negative 97. So we know that cos alpha is equal to negative 97 over 128, and alpha is equal to the inverse of cosine of that, which is equal to negative 97 divided by 128. So alpha is equal to 2.43 to 2 decimal places. However, that's not our answer. If we look back over here, we're not looking for alpha. Alpha is composed of angle AOD, angle DOC, and also angle COB. So COB is going to be the same thing as AOD just because this is symmetrical, therefore it's also going to be 0.5. So this here is going to be equal to alpha minus 0.5 minus 0.5. So DOC is equal to alpha, which is 2.43, minus 0.5 minus 0.5. And this is equal to 1.43 radians as required by the question. All right, so let's move on to the next question. So find the perimeter of the shaded region. So with the perimeter, we already have a few key things that we need. So we have what AB is, that's equal to 15. Then we have AD, BC, which are both equal to 4. We just need to find what DC is equal to. But the nice thing is that they already segued us into this by giving us the angle DOC, by making us find the angle DOC rather. So DOC is equal to 1.43 as we just deduced. And the radius, which is OC and OD, which is equal to 8 each. Now what we can actually use is the cosine rule to find what DC is. So if we label DC as A, or something like that, we can say that A squared is equal to 8 squared plus 8 squared minus 2 times 8 times 8 times cosine of 1.43. So let's just do that. So A squared is equal to 8 squared plus 8 squared minus 2 times 8 times 8 times the cosine of 1.43. So if we, well, this is already in the subject, so we just need to like simplify this down. So we know that 8 squared plus 8 squared is equal to 128. And then 2 times 8 times 8 is also equal to 128. So we have minus 128 cos 1.43. So we know that A squared is equal to 128. And then let's find what cos 1.43 is. So let's just cos 1.43 is equal to 0.140332. If we multiply that by 128, we get 17.96 approximately. So minus 17.96. So we know that A is equal to the square root of 128 minus 17.96, which is equal to 110.04, which is equal to 10.49. So now we know what the perimeter is, we just need to add them up. So 10.49 plus 15 plus 4 plus 4. 10.49 plus 15 plus 0.4 plus 0.4 equals perimeter. And that's equal to, let's just put this into our calculator. That's equal to 26.29 cm. And now they want us to find the area of the shaded regions in our next question. So if we go up here, let's try and figure out how we might do that. So there are two ways of doing this. Well, there are two things to do this, sorry. So what I was thinking we could do is find the area of triangle AOB, find the area of sector AOB, and then subtract the triangle from the sector to get the remaining. Well, no, that would not work either. Let's just think about this. So with the area, oh yes, sorry. What we can do is find, so they want A, B, C, D, that area over there. So this is worth 4 marks. It's a little bit complicated, it looks like. But we just need to think about what might get us the solution we want. So we could break this up into several parts. Or we could what we could do is find what the area of this part is. Let me just get rid of the A. Find the area of what this part is. Then we can find the area of what the sector is, the area of the triangle, and then subtract the area of the triangle from the area of the sector, and subtract this shaded area too as well. So let's find what this shaded area is. I'm just gonna inspect this. The way we can find this shaded area is by so what we can do is we can find the area of the sector, then find the area of triangle OCD. So triangle OCD, it has 1.43 as a central angle and 8 as side lengths. So we can actually use half AB sine C to do this. So A of OCD is equal to half 8 times 8 times sine 1.43. And if we put this into our calculator, so sine 1.43 times 8 times 8 times 0.5 is the same thing as 31.68. So we know what that area is. Now we can find the area of this sector. So this sector is angle 1.43 and side length of radius of 8. So sector area is half theta r squared. So area of sector, this sector is OCD. OCD is equal to half. Theta is 1.43. R squared is 8 squared. So that's equal to 64 over 232. 32 times 1.43 will be this area, which is equal to 45.76. So now we have 45.76 as the total area of the sector. We know that the curve, I don't know what else, the area of the curve, 76, area of curve CD, I believe it is equal to 45.76 minus 31.68. So minus 31.68 is equal to 14.08 cm squared. So now we have area of this like shaded region I've just shaded. We need to find the area of the shaded region that they want, which is the part in gray. And the way we can do this is we can find the area of triangle AOB, find the area of the sector AOB, Then subtract the area of the triangle from AOB, which gives us this portion over here, and then subtract the shaded area from that. So AOB, triangle AOB, A of AOB, so that's going to be equal to, so the total angle is 2.43 within O. 2.43, sorry, this is not 4, this is 8. My mistake. So 2.43 times, is sine of 2.43 times half times 8 will give us the area of that triangle. So is equal to half 8 times 8 times sine 2.43, which is equal to 32 sine 2.43. And sine 2.43, that gives us 20.90. Then the area of sector AOB is, I believe, what we want next. Sector AOB. So we know that the sector is half theta r squared. Theta in this case is 2.43. R is 8, so we get half times 8 times 8 times 2.43. And that's equal to 64 divided by 2 is 32. So 32 times 2.43 is equal to 77.76. So the area of what we think is curve AB, area of curve AB is equal to the area of the sector minus the area of the triangle. So that's 77.76 minus 20.9, which is equal to 56.86. So we have 56.86, but now we need to subtract this shaded region of the curve CD. So 56.86 minus 14.08 is equal to 56.86 minus 14.08. It gives us 42.78, which is equal to 42.8 cm squared approximately. So that'll be our answer. All right, now moving on to the next one. This is, I think, our last question. So congrats for sticking this far. So the curve y equals f of x passes through point half, comma 7 over 2, and it's such that derivative of f of x is equal to e to the power of 2x minus 1. Find the equation of the curve. So the derivative of f of x is equal to e to the power of 2x minus 1. Recall that if you have e to the power of f of x, where f of x is a function, the derivative is equal to the derivative of whatever that function is times e to the power of that function. So in this case, let's watch out for that. So we know, therefore, that if this is the derivative, then we have to integrate this to get f of x. So that's integral of e to the power of 2x minus 1 dx. In this case, integrating is the exact opposite. You have to basically divide it by whatever the derivative of this is. So that's equal to, so 2, you have to divide by 2. So you get half e to the power of 2x minus 1 plus c. So that's going to be the integral of that. And now what we want to do is substitute the point that we're given, half, comma 7 over 2. So f of half, which is equal to 7 over 2, is half times e to the power of 2 times half is 1, minus 1 is 0, plus c, which is equal to 7 over 2. And e to the power of 0 is equal to 1, so we know that 7 over 2 is equal to half plus c. C is therefore equal to 6 over 2, which is equal to 3. So therefore, the function that we have is f of x is equal to half e to the power of 2x minus 1 plus 3. All right, now we can go on to part 2. So find the value of x for which the derivative of, well, the second derivative of f of x equals 4, giving your answer in the form a plus b ln root 2, where a and b are constants. All right, so what we can do is take our value of the derivative of f of x, which is equal to e to the power of 2x minus 1. And if we differentiate that further, once more, to get 2e to the power of 2x minus 1. And they're asking us to find the value of x for which this is equal to 4. So we can say that this is equal to 4. And if we divide by 2 from both sides, we get e to the power of 2x minus 1 is equal to 2. If we take the ln of both sides in order to bring this 2x minus 1 down, we get 2x minus 1 is equal to ln 2. Therefore, we get 2x is equal to ln 2, and x is equal to ln 2 plus 1. X is equal to half ln 2 plus half, because 1 over 2 is just half, which gives us x is equal to ln root 2 plus half. And therefore, a is equal to half, b is equal to 1. And that's our answer. So we have just reached the end of this practice test. So good job for making it all the way through. Do let me know if you want me to see more walkthroughs, just to show you how I might approach a question. As I said, I'm also obviously not perfect at this, but I am just showing you like how I take steps in order to get these questions kind of right. So feel free to let me know if you have any different methods you want me to try and explore when solving these problems. And hopefully this video just helped you with testing strategy. So thanks for watching.